Good morning, good afternoon, and good evening, everyone. So today we're going to go through a test prep that consists of basically everything we've studied so far, which is from 13.4, which is about velocity and acceleration, functions of several variables. I don't know why that's not showing. Functions of several variables, and then we also did partial derivatives, as well as tangent planes and linear approximations, right? Okay, so let's go ahead and do our little test prep here. And I'm actually going to be timing myself, so I have to do this really fast, kind of. But anyways, okay, so I'm going to just start my timer. Um, and yeah, let's go. Let me just take a screenshot of this. Okay, taking a screenshot of the problem. Um, okay, so here we're being asked to find the linear approximation to fxy, and this is equal to this. Well, what did we say about linear approximation? Well, first we want to take partial derivatives. That's usually our first steps. Great. Now I can't. Okay, so our first step is to take partial derivatives. And then our next step is to find linearization. And then lastly, linear approximation. Right? Okay, so I take partial f of x. Wait, why is this not working? Yeah, for some reason, this is gonna make me waste my time. Anyway, okay, now I went somewhere. Um, there we go. Finally. Okay, much better. Okay, I'm gonna get f sub x. So I'm gonna take the derivative. Take the derivative. Let me just put this down. Yeah, I'm gonna do it live as well. Okay, I take the derivative. Here I see that my y is a constant. So let me just do that. This is 0. This is immediately 0. This one, well, we can just take the derivative of that. So here, okay, let me do a product rule here. So product rule, and here this gives me, well, x squared, this is 2x. This is x squared. And then this is just a number. So this becomes 0. Actually, this becomes nothing. So it's 2x cosine 3y. Done. F sub y. So I take the derivative of this again. F sub y in this case, well, let's do a chain rule here again. Cosine 3y. Here, this is a number, so I actually just take this out. Now I take the derivative of this thing, right? And so here, this just gives me x squared. This one gives me sine, or negative sine, of 3y. And then my chain rule, so that's times 3. And so I'm just left with negative 3x squared sine 3y. Done. Okay. Then I tried to find my points, right? Let me just quickly do that. So f sub x is going to give me 1, 0, right? Oh crap, I totally forgot about the square root. Oh shoot, my bad. Let me redo all of it. I totally forgot about this thing. Anyway, let me just take the derivative as a whole. Or actually, let me just do it. Like, I'll just do it directly. So here we have x squared cosine 3y. If I take the derivative of that, I'm going to get 2x, or well, chain rule. Bruh, I did not see that. Okay, that's fun. Cosine 3y. Here I get 2x cosine 3y plus x squared. Here I get sine, no, actually get 0 here. So I just get that. Next, y e to the 2y, well, that's just nothing. Cube root, oh, no, not cube root, square root of this. Well, this is the same as this. I take the derivative. This is minus 1/2, so I'm gonna say 2 cube root. So there. And then from there, what do I get? I get chain rule of this thing. And this one's gonna give me, well, x cubed, so that's 3x squared. And we're done. So I'm gonna say add to 3x squared over 2 of this thing. And I think, okay, now that should be it. Same thing for y. I take the derivative, I get God. What makes this long is the derivative, so I have to keep note of that. X squared, this is just a 0. So that's done. Y e to the 2y. Well, that's just I add. So again, I keep on doing product rule here. I see this as e to the 2y. That's just 1. Plus y. This one is e to the 2y again. I take the derivative, so it's 2. Now I have plus 2y. And then from here, I have e to the 2y. 1 plus 2y. Okay, so I have that piece. And what else? The last one is cube root. So 1 over 2. And then the chain rule. Well, here I just have 4. I divide 2, 1. So I have 2 over this cube root. Done. And then from there, I need to find my points, right? So I'm just going to do that. So my f sub x at 1, 0. Well, here I just plug in everything. So that's 2 cosine 0. Cosine 0 is 1. So that's 2 plus 3 times 1. That's 3. 2 square root 2 or 1. 1 plus or 1. So it's just this. Then I get 4 over 2, 7/2. F sub y. Well, here I get e to the 0, so that's 1. And then I get 1 plus 0, so that's 1 again. Plus 2 over, this is 1, 0, so plus 2. That's 3. 1 plus 2 is 3. Done. Now I find my linearization. How do I do that? Well, I have a formula for that. And my formula is that I need my f at that particular point. Then I add it to my linear things. So f sub x of AB is x minus a plus f sub y. AB is y minus b. And so let me just plug in everything I have. So f of AB. So here I plug in my 1, 0. Actually, let me just do that here. So 1, 0, 1, 0, 1, 1, 0, 0, right? And then from there, I can just say, oh, well, what is this now? F of 1, 0 is this. So I just do 1 squared cosine 0, 1. Done. Or cosine, am I right? Yeah, just 1 plus my f sub x is 7 over 2 plus 3 plus 3y. Done. That's my linearization. Finally, my linear approximation is when I try it out in a new point, right? So I'm saying that my f is approximately my linear. And so I just basically get f at 1, 0 is approximately my linearization, which is just 1 plus 7 half. I plug in my x and my y. I get 1, right? And so my linear approximation is just 1. And I hope I did get that. If I didn't, I'm going to be so sad. Let me take a quick screen. Oh my goodness. I should have just taken the screenshot of the whole thing. Anyway, let me quickly do that actually. Dang, that took a while because of taking derivatives. Wow, I did not expect that. I was thrown off guard. Okay, let me. So LXY, which is 1. Find linear approximation. Yeah, that looks. Let me just check. I think that looks right. When we find the linear approximation at a particular point, we just take their partial, right? We find their linearization, and then we just plug it in. But then, yeah, I mean, oh no, it doesn't want that. It wants this. It wants another formula. Yeah, it wants LXY. So I'm actually done with that previous statement. I didn't need to plug this in. Because in the WebAssign, it was trying to make me plug something in. So I just needed to plug in this thing. And next we use implicit differentiation to find this for the curve defined by this. So here I just, well, I take the derivative of both sides, right? I treat z as a function. So z is a function x and y. Well, here I think x is, oh, x is a variable, y is a constant. And so I treat it that way because I'm doing partials here. So let me just take the derivative of these two things. So this is, well, if we take the derivative of that, we get 3 and then my partial at z with respect to x. Yeah, that's it. And if I do x squared y e to the z, well, here I get, oh, I actually got a couple of things here. My y is out, so I leave it alone. And then now I have my x squared e to the z. I take this, I add, I take the derivative of that. Well, now I get y, I get 2x. I get e to the z, add, take the derivative e to the z, and then it's partial. Here we go. And so from there, I get 2x y e to the z plus x squared e to the z partial, right? Okay, what else? We have ln y. Well, ln y is just nothing, right? Because that's a constant. So we're left with this partial is equal to this. And then we want to isolate everything that has these things. Then we want to factor it out. See? And then now we want to completely isolate that thing. And that's it. What else? Done. Oh, I'm done. Is that my time? Timer. Oh, I have like 13 more minutes. Okay, but that was that. Let me quickly review before I get into some issues. Yeah, but that was it. Okay, I finished before like in 20 minutes. I'm gonna review though. Uh, okay. I think I messed up the derivatives. I'm gonna quickly check that. Right? Let me quickly check my partials. Did I get this though? I probably did. Okay. So when I take my partials, well then I want to get the derivative of each of these things, right? So let me just quickly do that. When I take the derivative of this, I'm gonna try doing it like one more because I have like what 13 minutes. I do a chain rule, right? So I do a chain rule. I swear I'm gonna make a mistake here. And I see, okay, well, this is in terms of x. And so that means I treat x as a variable here. I take its derivative like so. Copy, copy. 3y, well, that's a constant, so this becomes 0. Right? Because this is just a number at the end of the day. So this becomes a 0. And so I'm left with 2x cosine 3y, right? From that whole piece. That's the first piece. Now the second term, y equals, or y e due to the y, is just a number. And so all of that just becomes 0. Again, I'm treating it like a number. And then this square root with whatever is inside, well, if we take its derivative, we get 1 over 2 of this, set it up, chain rule. And then here we see this can be 3x squared. This one's 0, right? And so we got that. And that's how I managed to get that part. Now, for the other one, if we take the derivative again of x squared cosine 3y, I treat x squared as a constant, so I leave it be, right? I leave this be. Now this cosine, I make it negative and chain rule. So 3, and so here I get, well, I get negative 3x squared, right? Okay, I think I messed that part up. Cosine 3y. Now I don't know where that went here. I actually don't know where that went there. Now my y e to the God. My y e to the 2y. Oh shoot, I actually did not consider this one. Oh crap. Okay, that's bad. Yeah, because this is a constant. Yeah, I have to consider this. Okay. So let me put that here maybe. Okay. And then now I have this next term, y e to the 2y. Let me just do a product rule. And then I see here, oh, this is e to the 2y. This is y. This is e to the 2y. This is 2. So I have, yeah, e to the 2y. I factored it out, and I have 1 plus 2y. And so, okay, I got that part. Now, how about this thing? Well, I do the same thing. Put this here. Chain rule. Well, x cubed is a constant, so this is 0. 4y is 4. So I divide, I get that. So actually, I left this part out, right? Okay, and then now I plug in the numbers. So 1, 0. Let me just quickly do that. I plug this in for 1. This becomes 3. I plug this for 1, 0. 4 times 0. That's 3 halves. Where in the world did I get 7? Oh, this is 3 halves. I added to this one. So 2 times 1 is 2. 0 cosine 0 is 1. So 2 times 1 is 2. And then I can do it 4 over 2. 4 plus 3 is 7, 7 halves. So that's where I got that. Now here, this is going to be different. E to the 2y, I plug in the zeros, I get 1. I get 1, right? Because I plug in the 0, I get 1. 1 plus 2 over something. 1 plus 0, so 1 plus 2, 3. So that's 3 minus this one. 3 times 1. That's just 3. Cosine of something. Cosine of 0. So, oh, look at that. Cosine of 0 is 1. Right? Let me see if I'm not mistaking anything. Oh, look at that. I get 0. I actually get 0 here. Funny enough. And then from there, let me write it out. And then here, instead of 3, this is 0. So actually, that's it. That's the difference. Okay. Now I can be a bit more confident that this is actually the right thing. I can write the 0y just for fun. Boy. There we go. And then we now use implicit diff. Here I treat z as a function, right? With respect to x. So x is the variable, y is the constant. So here it's about determining which one is the function. So in this case, it's this upper thing. Which one is the variable? So in this case, it's x, because that's what it's respecting it to. And then y is the constant. which we're completely ignoring. So let me just quickly take derivatives. 3z plus 1, 1 is constant, that's 0. This is 0. 3z, well, we get 3, and then z prime. So we get that notation. And then x squared y z, we did a product rule here. We left my y, right, because that's completely constant. Now we're left with this product rule. And then we have 2x, right? X is a variable, easy. X squared, easy. And then z prime. So that partial, 2xy e to the z. We just combined it. X squared ez. Okay, my z is being confused with my 2. Anyways, now we get this. And then from there, we just combined everything. Combine, put all of the partials together, factor it out. God, my z and my 2 look the same. Wow. Yeah, my z and my 2 look the same. Okay, we factor out the 3 minus x squared ez, or factor out the partial, right? We divide, done. Let me check my time. I have like how many more minutes? I have 4 minutes. Anything else? I think that was it. Yeah, that was it. Okay, maybe just to check. I don't really know what else to do. Did I get it though? Yeah, let me just check because I'm pretty much done. Is there a way we can check? 14.4. Yeah, linear approximations. How did I do it in the homework? It's usually this, the way you do it in the homework. My linear approximation is just my linearization. It's just that. But we're not using it to approximate anything, right? Uh, cool. Okay, so this is why I don't. This is the part where I just don't know what to do after a test because I finished quite early. Uh, yeah. So I find linearization, right? Um, I find their linear approximation. Well, I don't need to do that in this case, so kind of did that here. And I don't think I messed up derivatives, or did I? Oh, shoot. Did I mess up derivatives? Oh, wait, I think I did. Look at that. Cosine 3y. This one's it's a constant. That's the thing. If it's a constant, we just leave it there. Y2y is a complete constant, so we don't do anything. Here, this is just there. Um, I really don't know where I'm probably messed up. Let me see. Here I got this one now. Hopefully, question mark. Uh, 2 over, unless I messed up derivatives. Next time I'm gonna take it slow, maybe. My x squared is there. Chain rule. Oh, look at that. This is sine. See, I knew I would mess something up. Okay, now what is this? Sine of 0 is, right? Because I plug in my thing, I get 0. I still get 0 at the end of the day. Yeah, I think. This gives me a 1. This gives me a 2. That's 3. Minus 0. Oh, look at that. This is 3. So now I got back to my 3 here. Oh my goodness. So now I have 3 here. And so that means, or no, my bad. I have 0 here. Now I have a 3 here. So plus 3y. What else did I miss? I know I missed something. There's no way. It has to be the derivatives part. Cube root, I think I got it. 1 over 2 squared of this. Take the chain rule. Take this part. Boom, done. This one's constant, so that's 0. Yeah, I knew I got this one. How about this? X squared, I got that. Plus this, y e to y. Yeah, I got that. Do that many times. 1 over 2 squared of this with 4. I take this out, I get this. Yeah, I can't tell anymore because I rushed it too much. I plug in. So 1, 0. Cosine 0 is 1. Yeah, this is 2. 0. Yeah, I know I got that. This one I know I probably got. Yeah, I think yeah, this should be it. And if I check my linearization, what do I have? God. Okay, 1 second. Okay, done. Um, okay, I'm just gonna check the solutions. Let's see if we got it. More like check GPT, because there's no solutions. So I'm just gonna do that. Uh, okay. Let me see. So first, give yourself a half hour to complete. Grade your work. Use book, other resources. Rewrite your solutions, and then upload. Okay, let me just check. See if we got it, actually. Because I feel like we didn't. I'm just messing about. Try again. No. What? Oh my god. My phone just screamed. That's funny. Okay. My phone screamed. That's so okay. That was funny. You don't have to get it. Okay, anyways. So let me find approximation. Let's look at it actually. Let me do this, right? Let me look at GPT. Doesn't hurt. So we're being asked to find a linear approximation to f y equals x squared cosine 3y uh plus y e to the y. I'm just making sure I type it right. Plus, I don't know how you go square root. Square root of oh of cube plus 4y. And it should be at the point 1, 0. Okay, let me see. Did I type it right? X squared cosine 3y. Yeah, looks like that's it. So a tangent plane to this function. And so let's do it. Yeah, so we did do the formula. So we got that part. So I'm just going to show where I did that. So that formula is this thing. There. That's that formula. Instead of 1, 0, it's AB. But I know when I was solving it, I changed it to 1, 0. As well as this one. So this was A, this was B, right? Okay, and let me go back. Let me go back. So it's here. Okay, let's see. So yeah, we need our f sub x and f sub y. Our f is actually 2 in this case. So I did mess up one of them. Yeah. Apparently my arithmetic is bad. I put 1, I think. Yeah, I put 1, but it should have been 2. Why is it 2 again? Okay, I actually try solving it slowly. This is f1, 0. This is 1 squared cosine 0. Cosine 0 is 1. So I actually have 1 here. y e to the 2y. Well, this is 0, so it doesn't matter. Cube root. There's a cube root. 1 plus 0. Oh, look at that. I actually got supposed to be 2. So yeah, just some solving issues. This one's supposed to be 2. Oh, I think I know why. I didn't see this cube. I think that's why. So this one's supposed to be 2. Okay, and let me go back. So that's supposed to be 2. My partial derivatives f sub x, so that's correct. 7 halves, right? We did get that. With respect to y, we also did get that. That's good. 2y. Did we get the same thing? 2y? I totally forgot. Oh yeah, we did. 1 plus 2y. Yeah, so we did get the same thing. Share back to here. Okay, let me evaluate. I want to see the answers. So 7 halves and 3. And so 2 plus 7 halves x minus 1 plus 3y. And yes, we did get that, right? So it's voila. There we have it. So it's just a slight miscalculation on the 2 part. But overall, we did get the concept, right? We understood the steps, and that's good. Okay, now we do implicit differentiation. Do I just share or like... Okay, I'll just share GPT. I'll type it out. Okay, so we're being asked to use... I don't know how to do the partial simple, so use implicit differentiation to find partial derivative of z with respect to x for the curve find. This one's going to be 3z plus 1. I'm going to equate that to x squared y e to the z plus natural log of y. And let's do it. So yeah, we do with respect to x. So let's see. Okay, so the left-hand side, which we did get, 3z plus 1 is that. The right-hand side is, well, we do a product rule in this case. And there we go. 2xy e to the z, x squared y e to the z times its partial. And ln of y is 0 because y is constant with respect to x. And so if we combine both sides, blah, 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 we got this. 2xy e to the z, 3 minus x squared y e to the z, which I think we did get that part. Let me double check. Yeah, we did get it. Okay, just to be sure about the... Oh, I forgot about the y. I just realized. There's a y here. There has to be a y there. Why is that? Why is that? Did I mess up something again? I probably did. Let me see. Okay. Oh, yeah. So I was supposed to do this, multiply my y. And so I should have a y here as well, right? Because I'm multiplying y to both my terms here. So it was a total mistake. Yeah, and then my y, and then my y, and then yeah, my y, and then that was it. I just add my y here. X squared y e to the z, right? Yeah. Yeah, I think I'm a bit confident. Yeah, this looks all right. The idea is we get the process, right, of how we did it. Um, yeah, I mean, that's it for this video. It was just a quick test prep. I hope you guys enjoyed, and I'll see you all in the next one.